Okay, so what I'd like to talk about today, we've been talking the last couple of classes about statistics, we talked about distributions, we talked about significance testing. One area that is important is this notion of exploratory data analysis, which is this idea that, how do you take data and how do you look at it so that you can see what it's really saying. And, properly, carefully looking at your data before doing your analysis, in my mind, is one of the most important things in any of these kind of projects. If you look at your data, you should be able to identify if there are artifacts in how it was collected or processed. Okay, you should be able to look at distributions to see whether or not the data the distribution that a variable has looks like what it should be. Okay, you should be able to make hypotheses from looking at the class. Okay, from looking at the data. Okay, so one thing that a lot of students do that to my mind is asking for trouble is, we'll be talking about machine learning algorithms on here. A lot of students get a blank look in their eye and start saying, well, I'll take my data and feed it to a machine learning algorithm and it will figure everything out. If you have a problem in your data, okay, that is of a fundamental notion. If you haven't looked at it, you're asking for trouble. This is one thing that I firmly believe and has been well bared out in my experiences. Okay? Any questions? So how do you look at it? Okay? And there's this field of data visualization that is now a relatively well-defined notion. And chapter 6 of the book is on visualization. And I think visualization is one of these things that people think is very easy because they can go to Excel and they can draw a plot of any data that they want. But there is a big difference between a good plot and a terrible plot. Okay, and it's sort of important to sensitize yourself to what is a meaningful visualization and what isn't a meaningful visualization. Because on one level, it seems like maybe it should be obvious, but there's enough experience I have that these things are not obvious. Visualization is one of these things that is harder than it looks, okay? And for that reason, we need to think about it a little bit carefully. Any questions? Okay, so one of the classic examples as to why data visualization is important is something called Ascombe's Quartet. These are 4 sets of, I believe they are 11 points each, which have the following properties. Every one of these 4 sets has the same mean. It has the same variance. Okay? It has the same correlation between x and y. Okay? It's fit by the same regression line. Okay? The question is, are these data sets the same? Okay? They're the same by all summary statistics. Do they look the same? Can anyone? What?
It is not necessary that they are same. They might be different.
Not necessarily. Okay. Now, can anyone tell me anything from looking at these numbers that is suspicious? Okay. The answer in my mind is not obviously. Okay. But if you draw pictures, suddenly you see that these data sets are wildly different. Okay. And they tell you different stories. What is the story of this data set? Okay? Can anyone tell me a story? Again, part of it is learning how to read data, to look at data and tell a story. What is the story of this data set? Okay, if one had to describe it. What? Positive correlation. I would say linear, a linear trend, but but noise in it, right? Noisy linear trend. What would this one tell me? Okay. This is probably, is this a linear fit? Is this it's probably some quadratic, it's some quadratic curve. Okay, and it looks like it's a pretty tight fit actually along that, right? What does this one tell you? Linear with an outlier, not so much noise, but an outlier. And what is this one? I would say this is constant with an outlier, right? That, you know, in some sense, y is independent, completely independent of x, with the exception of a, you know, an outlier element, right? Does everybody see that? And again, these interpretations are obvious once you see the plot, okay? But this is why just collecting summary statistics is not enough. Any questions? Yeah.
How do you differentiate between noise and outlier?
How do I determine between noise and outlier? Okay, again, it's a question of what story do you want to tell. These, to me, look like one point each that is wildly out of sync with the others. Okay? And it could be a management, you know, but if you look at it, if you delete it, the standard deviation goes down considerably, you know, to essentially nothing, right? The variance goes down. The residual error from the fit goes down to nothing. Okay? Here you delete any one of the points, the worst point, the residual fit goes down slightly, right? So there's a different process in these two figures, x3 and x4, than there is in x1. Okay? And when I see an outlier like that, it requires an interpretation. Maybe it is somebody who really does have this property that, you know, maybe, you know, what could x be and what could y be that, you know, maybe this is measuring. Maybe this is representing, you know, food consumed each day. And this was Thanksgiving, which is the big American holiday where people eat a lot more. So maybe there's an outlier like that. But quite often I would say there's an artifact or an, you know, some substantive data collection problem associated with the point. And that probably the better thing to do is to understand why they look at these points carefully, decide if they're real, and if not, maybe toss them out. Okay? Any questions? Okay? But the clear picture is that once you see them on a plot, the answer is obvious. Okay? Any questions? And these days, you guys are saying, yeah, I like to draw pictures. I like to use plots and stuff like that. This was probably, you know, it's something that, you know, people are getting more visual at looking at data sets, and this is the right way to think about it. Any questions? Okay, now we're going to try to talk over the next couple of classes about what is a good visualization and what is a bad visualization. Now, some of this I would like to say is subjective, that I am, you know, that one visualization is obviously better than another. But some of it I will claim is a question of taste. Okay? Is anybody familiar with either of these pieces of art? Who knows which figure this painting this is? Yeah? This is a Jackson Pollock, okay? This is, does anyone know who this one did? This is Jacques-Louis David's Death of Socrates, okay? And both of them are on view at the Metropolitan Museum of Art in New York, and, you know, which is a good place you should visit. Now, which one of these paintings is better? Okay? I mean, again, you know, how do you decide these things? One way to do it is to take a poll. Who here thinks Death of Socrates is a better painting? Okay. Who here thinks that Jackson Pollock is a better painting? Okay. We have some Jackson Pollock fans. The answer, of course, is I don't think that there is a right answer here on some level. You know, in order to appreciate what you like better, you need to have some kind of a taste. Okay. And, you know, developing, though, a taste for a particular visual aesthetic is something that is worth learning. Okay. That, you know, to decide that this is a good thing requires some kind of an appreciation of something different than what you saw here. Here people are talking about the energy in it, and people are talking about the liveliness of it. And here people are talking about the photorealism of it and the pathos of it and stuff like that. And so likewise, when we think about analyzing graphics and data presentations, we need to develop a particular visual aesthetic, okay? It's not enough to say, I like this and I don't like this. It's enough to say, you need to have a reason as to what you like and what you don't like. So my visual aesthetic, for a visualization aesthetic for data, comes a lot from some. It's from experience and there's taste and all this. A lot of it comes from a guy named Edward Tufte. Has anybody ever seen any of Edward Tufte's books on visualizing data? One person does. These are fabulous, fabulous books to read. And they are fabulous books to read in the toilet because they're mostly pictures about, a book of pictures of good mathematical graphics and bad mathematical graphics. And you start to develop a taste for what you want to see. And Tufte has developed a vocabulary to talk about these things that gives you a language to say, instead of whether something is good or bad, what makes it good or bad. And so there's sort of four main principles that I get from reading Tufte that when I look at graphics, I think about. One is this idea of a data-ink ratio. I want to maximize the amount of data for unit ink in the paper, in the visualization. I would like to minimize the lie factor. I want to see that the data is kind of presenting, the graphic is sort of showing what the data is really saying. Okay? I want to minimize what he calls Chartjunk, things that don't belong on a graphic, okay, that don't really contribute to understanding. And I want to stress things like proper labeling and scales in order to make it, make clear what the data is really saying. So I'd like to go through these and hope that you will develop a visualization aesthetic, okay, as to which is better. Here we have two sets of bar charts. Everybody's seen bar charts before. Which one do you like better? Do you like this one? Or do you like this one? Okay, let's take a vote. Who likes the one on the left? Okay, with the fancy 3D effects, right? That's cool, right? Who likes the one on the right? Okay, everybody here. Well, Tufte would tell you he likes the one on the right. And so do I. Why? Because there is a lot of ink here that is being used that is not being used to display data. What ink here is not being used to display data? The shadows. Everything that shadow is pretty cool, right? But does that tell you anything about the data? Okay. Was there anything else here that is a cool effect that is not designed to show you data? What? The three-dimensional thing, right? Does everybody see that? Those blocks, in order to cast shadow, they had to be blocks, right? And does that tell you anything about it? Okay? Anything else about here that, in terms of, Chartjunk or data ink that you don't see? What? The width, one might argue that by this measure, if our goal is to minimize the amount of ink that we use, one possibility might be we'd want to represent these bars thinner. Okay? That would be, consistent with that aesthetic. Okay? What else don't you like about this? Okay? Right? What else don't I like about this? This three-dimensional thing, the fact that it's turned on its axis to show off the shadow and all that. Does that help in the interpretation or hurt in the interpretation? It clearly hurts because, by definition, the fact that this is receding away from you means that you're disproportionately going to think this bar is bigger than that bar. Does everybody see that? Okay? So again, one of our goals, we want to maximize in a graphic the amount of ink that's devoted to presenting the data in a meaningful way. Any questions? There is this notion of the lie factor, which is one thing that Tufte talks about, which is the way he defines it, it's sort of the size of an effect in the graphic over the size of the effect in the data. So if you see something if there's a twofold difference in the data, you'd like there to be a twofold difference in the graphic here. Okay? Now look at this graphic. Do you see any, this is showing you how doctors devoted to family practice is going down. Okay? Does it look like, is the size of the, is the size of the image, okay, reflecting the size of, accurately reflecting the size of the magnitude of change? Now let's think about it. How much has this changed? Okay, is the in 1964 it was 27%. Now it's 12%. That to me says that the change from here to here, it got halved and a little bit more, right? Is the size of the doctor a half the size of this doctor, or is it more or less? What? You say it's a third. What I suspect happened, I probably could have measured this. I believe that the height of the doctor is probably 12/27th the height of this doctor. But notice that the doctor is a two-dimensional thing, right? And what you're seeing is the area of the doctor. Does everybody see that? And if you see that, then this doctor, area-wise, because he's scaled, is going to be more than that. Does everybody see that? Okay? So you've got to be careful when you look at graphics whether or not it's showing you what you think it's going to be. And again, there's a similar notion here in this notion of oil prices going up. If you look at it, the difference between this and this is $3 a barrel. The difference between this and this is a factor of 3. It doesn't look like it's a proper perspective because it's using sort of three-dimensional things to represent two-dimensional things. Any questions? Another notion that's probably, you guys are saying, well, we usually don't draw graphs like that. A bigger sin that people do when they draw graphs like this is more often like this, where they don't show the scale starting at 0. So here is a graph from a particular media outlet that is known to have a certain political slant that is showing you how the change of tax rate went, okay, after certain tax cuts expired. And what do we look at? What is your impression looking at this graph? It's an enormous thing, right? And this is another representation of the same data. And is this an enormous change, or is this an incremental change? This is incremental. What is the difference here? Scale, it's really the starting point, actually. This starts at x equals 30, at y equals 34. This starts at 0, right? And so, in generally speaking, if you want to show proportionality of these things, starting at 0 is an important thing to do. Any questions? Okay. There may be sometimes reasons where you don't want to start at, at 0. But generally speaking, you want to start at 0. Okay. Especially if the purpose is to compare magnitudes here, then that would be the argument. Any questions? Okay. Yeah.
When might we want to look at data with not 0, like starting from somewhere, as you told?
So sometimes so generally speaking, when I draw my plots and I have my students draw their plots, I started at 0. Occasionally, the difference in magnitude is so small, okay, that nothing shows up then. There might be a real difference between things, and the magnitude doesn't show up, in which case one has to be careful. There's ways to kind of show this differently. There's different graphical devices that you can use sometimes instead of showing the whole tower to kind of focus on a relatively small difference without losing the whole sight of it. Has anybody ever seen a graph where they tried to show that they weren't? How would you show that you're not showing the bars? Or what graphic device might you use to show people you're not showing the whole bars? Okay. Has anybody ever seen a figure that looks like this on a graph, where maybe they'll show you something that looks like, okay, where they sort of show that there's a cutout to show that they're not showing everything, right? That then helps clue it helps clue in what you're trying to do. Any questions? Okay. So it's important to think about what you're trying to see, what you're trying to show, and how they're going to interpret it. Generally speaking, you're living in sin if you don't start from 0, okay, unless there's a good reason for it. Any questions? Okay, good. Another aspect of how presentation can affect, let's say, how you interpret these things. Which one of these drops in sales is most calamitous? Okay, this company has obviously, one of these companies is going through a terrible period and their sales plunged. Which company is it? Does everyone agree these guys are, are one step from the grave, right? Does everybody see that? Which company is going through what is basically a mild downturn? The bottom one. And what is the difference between the data? The answer is there is no difference in the data. Okay, there is a difference in the aspect ratio of the plot. Does everybody kind of see that? And that the interpretation, there's no question that, if we were talking about, if this was a graph of the economy, if you had two presidential candidates arguing it out, depending upon who they are, one of them would pick this, and one of them would pick that, right? So how do you design a graph that isn't really lying? Okay? In general, there's a couple of things that people note. People seem to understand 45-degree lines as just a normal thing. Okay? People also seem to be used to charts of certain ratios. This is an unusually compressed representation, and this is an unusually stretched chart. Does everybody see that? And so typically there's this notion of the golden ratio, which is like 1 to 1.6. That is the length of a plot that people are typically used to. Okay? Any questions about that? People should be aware that these are the kind of things you can do to distort the meaning.
So do you really think the top left is better than the bottom? Because to me, I mean, you're more context the better in regard to the...
These are exactly the same numbers.
No, I know that.
Yeah.
But I'm saying you're arguing, right, that the top one is the best representation because it's...
I would argue that the top one is probably the best representation. To my taste, and again, some of this is taste, I would say that this is the best one. And one of the reasons, like I said, I think that has to do with standardization of what people are used to seeing. Okay? People are used to seeing graphics of this this sort of, I will say, sort of proportionality of x to y. Okay? And so therefore we have built a certain sense for interpreting them. And, having wildly different perspectives, are more likely to be misinterpreted. Again, this is a question of taste, and there's different context and things like this. But generally speaking, I think it's an argument that you would want to use a standard layout, standard aspect ratio, unless there's a really good reason not. That's, I guess, my general feeling. Yeah.
If you consider data in ratio, then probably second one will be the best, right?
Well, you say that this one you're saying has a better data-ink ratio because it's the same amount of data and it's smaller. You could interpret it that way. But again, I could make that even better by shrinking the plot to the point where you couldn't see it, right? Do you agree that that would have the best data-ink ratio? Okay? So they recognize that in judging these aesthetics, there's different, none of these are absolute rules by themselves. But there are criteria, and there's a bunch of different trade-offs. We agree that making the data smaller, the plot smaller, will increase the data-ink ratio. Okay? Actually, is that true? That's actually not true, come to think of it, because I think that it's the data-ink versus the total ink in the graphic. And so I think that actually, by this measure, actually, they're both constant. Okay? Does everybody see that? So I don't think that that's, that point is there. But the bigger point is, what's good about this is not that any of them are hard and fast rules. The good thing is that they are aesthetics, and you're starting to talk about things in a way that, you can have an intelligent discussion about. Okay? Any questions about it? Okay. So that's about lie ratios. And here's another example that I liked. And some of these examples come from Tufte's book. This is one that was showing fuel efficiency standards as a function of time. Okay? Does everybody see it? What does this figure show if you look at it? Here's the year. Here's the fuel efficiency. Okay? What does this graphic show? Okay? Yeah? It shows that it's raised it over the years, but not only that, to me, this looks like, my God, it's out of control. This is what it was only 10 years ago. And this is what it is now. Does everybody see it? The length of the line is reflecting the size of the, but the real number was 18 going to 27. This is the exact same data plotted on one where you have, what you call it, you go down to y equals 0, and you plot the data without, trying to impose some kind of a vision here. Any questions? So again, it's important, typically when you're showing data, you often have a point you're trying to make. It's important that you not, turn into too much of an advocate. But
like seeing the examples, it feels like that if we create a simple plot like that one, it generally is better than creating something fancy like this one. Is it true?
yes, I think that generally a lot of graphic devices, adding fancy for the sake of fancy doesn't help. That's kind of, I guess, in my aesthetic. Okay? Now, there are things that do help in presenting data, and we'll look at these things later on. But recognize that adding effects for the sake of adding effects doesn't help. Any questions? Again, the idea of adding effects that show effects, this is what you call, Tufte calls Chartjunk. Okay? And this is where you add extra elements to your data, okay, to your plot, that often distract what the story you're trying to tell is. Sometimes things like the extra dimensionality can be thought of as Chartjunk. Adding colors that don't really inform something for a reason is Chartjunk. Adding figurative decoration and extra grids is Chartjunk. Okay? Again, in an exciting graphic, it's the data that's telling a story, and you don't want the graphic arts to be telling a story. So one thing, these are two examples from Tufte's book that I am fond of. One is this one over here, which is, you may not be able to read the numbers here, but this is a plot of, over a certain number of years, what percentage of the population, what percentage of the college population was under 21 versus over 21. Does everybody see that? One of these plots is showing what fraction of the population is over 21. One is showing what fraction of the plots is under 21. What here looks like Chartjunk, or what are we seeing? Yeah? First of all, the three-dimensionality is unnecessary. Does everybody agree? What else is it? Now let's turn it to 2 dimensions and just assume we've only got the red and the yellow. What else here is kind of unnecessary visualization? Yeah?
What are those like lines, those segments I can't see?
Which segments?
Yeah, it's like,
This? Well, this is showing the point as it's projecting out. Presumably these would go away if you went down to 2 dimensions. But is there other stuff that's visual elements here? That, yeah? You're saying that the coloring of the area doesn't help. Okay, it doesn't really convey information. I think I believe that. Are there any other things here? Okay, what is the actual data in this plot? Okay, how many data points are there in this plot? Okay, this is showing the college, this is the year. This over here is showing the fraction of college students of age 21 and over versus 21 and under. Okay? You're saying you should try to discretize it per year. Well, actually, they do discretize it per year. This is only 5 data points. Okay, 1, 2, 3, 4, 5. See how, oh, sorry, boop, boop. See if we get rid of this, kind of how do I get rid of that thing? How do I get rid of this thing over here? If I hit exit, is it going to melt the machine down or no? Ah, yes, it will. Okay, let's go back there. Present, boom. Does everybody see that this is only 5 years worth of data? This is not a continuous thing. Okay? So all that this is showing really are those 5 data points, which are the percentage of people who are under 21, and 5 more data points for those percentages that are over 21. Okay? But do the percentages over 21 make a difference? Do they show us any more information? It's 100 minus that number. Does everybody see that? So this entire thing above is unnecessary. Does everybody see it? What else is unnecessary on this one and misleading? Why do you think this was continuous? It's showing the area under the graph, but in my mind what makes it even more look like that is the fact that there are all these different shapes of curves linking these 5 points. Is there any interpolation being done here? What is the interpolation model here? God knows, right? This is really just a plot of 5 points, okay? And would be wildly easier to understand with x being 5 values and y just showing those 5 points. Does everybody see that? So Chartjunk is, this was Tufte's vote for the worst mathematical graphic ever to appear in print, okay? So that's it. So thinking about when you look at a graphic to try to remove things that are extraneous elements, there's sort of a less is more aesthetic that is kind of important. Any questions? Does anybody know what this building is or where it is? Yeah, you know where it is. Where is it? This is in Flanders, Long Island. This is the Long Island Duck, okay? This is a building that somebody built, and it looks like a duck, okay? Now, you know, does the fact that it's a duck help it as a building? Okay, not you know, if we believe form and function, there's no function form here. It did sell duck eggs at one point. That was the reason why they made it shaped like a duck. But typically, but it's actually, this is a famous building in the architectural / design literature, just because people call this extraneous thing ducks in honor of the building. So next time you go towards the Hamptons, make it a point to look up and visit the Long Island Duck, okay, on the way there. Any questions? We want to design our charts to avoid ducks, okay? So let's look at this plot and see if there is any way we can simplify it. This looks like this is something like a percentage of sales coming from some channel in a particular month. Is there any way that we can simplify this data, this chart? What? You say remove the background color. Okay? What? The vertical lines. Do we believe the grid is doing us much good? Okay. You like the horizontal lines, but you definitely don't like the vertical lines. Why do you like the horizontal lines?
I mean, it's just hard to get a read on exactly where something falls.
So horizontal grid lines do have an effect for telling you where what a value actually is, right? But putting data, often tables and plots like this, in these grids, or I've heard these things called data prisons, because they look like the bars on a jail cell, right? So how can we simplify this plot? Well, the first thing is, I think most of us agree, is get rid of the data prison, and at the very least, keeping these tick marks gives you some indication as to where the lines are, right? You wanted to get rid of the background color, okay, and that I agree with. It makes it better. Anything else we can get rid of? The boundary box around the sides seems to be convincing us of nothing. Does everybody agree with that? Is there anything else we can remove from this plot? The color inside the bars? Maybe. We could have the outline, okay, although, you know, there is some question. Again, there's it could be. I might argue maybe you make your bars thinner. The other idea that they took out was they took some of the bar away to show the lines that this guy wanted, right? You wanted those lines? Now you got the lines back without actually drawing them. Does everybody see it? So people like this one, right? Okay, and so learning to think about what is it that you want your graphic to see, developing a taste for this is kind of an important thing. Okay, any questions? Okay, fair enough. And what I will tell you is you guys are now all ace Python programmers, if I understand correctly. And the matplotlib library in Python does give you access to an amazing variety of charts, including things like, pretty much just like what I just showed you, right? So often if you look carefully enough at your plotting library, the lesson here should be the default settings of your plotting library do not necessarily produce the best plot. And it is worth playing around with it and worth developing, looking through the options and developing an aesthetic of what you can do, okay, so your plots look good. Any questions about that? This, I think, is important. Any questions? So, it's important to sort of be aware of what kind of plots are there that are available for what you want to do. Okay, this is a figure that I have, the guy that made this figure graciously let me put it in the book, okay, because I thought this was really good. But this is kind of a flow chart of, of different, let's say, chart types that lets you help make decisions of which kind of chart types would you like to do, okay? So, for example, sometimes you have variables and you want to show their relative relationship to each other. That would be typically a scatter plot or a dot plot, okay, or bubble charts, these things, if you have 2 dimensions or 3 dimensions, okay? Sometimes you want to show comparisons between things. Why is it that you have bar charts? Bar charts exist so you can compare different quantities and see for yourself which is larger or which is smaller. Does everybody see that? And there's different variations of bar charts and stuff like that. Sometimes you're interested in comparing things over time. And that's typically where you start having line charts, where your x-axis is now representing time, right? Okay? Sometimes you want to show distributions. Maybe you want to plot it as a histogram. Maybe you want to plot it as a more quantized histogram. Stuff like this. Sometimes you want to show whether or not your, how you partition a fraction of things among different things. That's where pie charts come in. Bottom line is, there are a lot of charts, and I want us to kind of go through and look at them to try to develop some taste as to how we use them. Any questions? Okay, good. So the first kind of plot that I think is the simplest plot that is worth looking at, because even though it's very simple, there still are enough degrees of freedom to try to appreciate, had to do with tables. Why might people like tables of data rather than plots? When are plots good and when are tables of data good? Does anyone have a taste for this? Yeah?
Exact values, I mean, you can just look it up and get a reading.
When you want to show precise values of things, you probably want the numbers in a table, right? When you want to show something about what the precision is that you're measuring these things with, you can see those numbers in a table. So for showing these things, tables are better. What other kinds of things are there? Yeah? You can show multiple dimensional data. The interesting thing is, if we view every column as being different data, you can show many, many different dimensions in some sense at one plot. If you show a cloud of points in 2 dimensions, I understand it. If you show a cloud of points in 3 dimensions, I already get confused. How do you show clouds of points in 5, 6, 7 dimensions? The answer is typically you don't, at least not to me. Typically, a data table is a good way to do it, right? Does everybody see it? Tables can capture heterogeneous data better, right? So you can have a mix of numbers and things that aren't numbers, like labels and things like that, right? So tables are good things. And as for small numbers of points, frankly, data tables can be more compact than actually the graph. I occasionally have students who will proudly put a paper in a graph that looks like this. And I don't think that they need the full richness of the plot for that. Any questions? So here is a table. You guys remember we did something on on viewing data of countries. Here is data of countries. How can we improve this table, or is this table good? Okay. Does anybody look at this table? Is there any way you can make this table better? Yeah? One thing is it doesn't show the units, so you would you would somewhere want to show what the units are, perhaps on the caption up here, perhaps on the heading titles up here, perhaps on the label below. Okay? Yeah? So one degree of freedom you haven't exploited here is the order to permute the countries. Okay, does everybody see that in a table you have complete freedom on how you order the rows, right? What ways to order the rows might be good? You're saying sort the countries by what?
I would say
Alphabetically. What is good about sorting it alphabetically? You can look up for a country more easily. Are there any other ways that you might want to sort them? What? Data-wise. If there is one column that is particularly important, that's showing a particular, if your agenda is to show a particular relation, maybe it pays to sort that. But certainly you would want to, sort things, take advantage of the freedom to permute the columns, the rows. Any questions? Anything else we can do to make a better table? Yeah? So one thing is, what number is this? I can't read that number, right? So putting commas in the numbers probably makes it easier. If the number is big enough, you want them to be made so you can read them, right? Does everybody agree with that? Anything else we can do to make this a better table? You can permute the columns so that related columns have to be. So what would be relative related? What would be a way to order the columns so that the more related columns are probably near each other? Okay, in this case, yeah? Birth rate and mortality might be more appropriate because they say they're topic-wise better. Area and density and population all have something to do with the sizeness of the country. Maybe those logically belong together. Okay, does everybody see that? Okay, and again, we can quibble about it. I would probably say area and population are probably directly correlated, so those probably belong more closely together. The things that you want to do comparisons with on your eye, you want those to be together, right? And those are facilitated when they're together. Is there anything else that we can do? Yeah?
Maybe you can sort the rows, so we can just search one record really quick, say sort by the country name.
So sorting by country name would be a good idea. We agree. Permuting by rows, permuting by columns. Is there anything else that we could do to show off something? Yeah?
There is a column which we can derive from two other columns. Simply drop it.
Saying if there's a column, we could derive it from another column. So what you might be saying, drop density because area and population are both given. Let's take a vote on that one. How many people think the density has something to show us here that's different? Okay? I personally think that the density makes something clear. I cannot look at area and population and by itself derive density. Like, gee, it's interesting. Which countries are dense? Okay, Israel's dense. Okay, what other country? Japan is dense. Okay, that's interesting, right? What countries are, oh, look, Tonga. Tonga is that little island, right? And they're surprisingly dense on that little island, right? And some of these other countries, so I think that showing density probably is revealing here, okay? In general, if it's an obvious correlation, a direct thing, showing area in square meters and area in square miles would be dumb, right? But I think that you can show derived statistics. I think they're interesting. Any questions? Anything else we can do to make this a better plot?
We can probably represent every number in same number of digits. For example, in the mortality, I can put two numbers after decimal in every number.
Okay, so what you want to do is to make everything have the same number of digits. So on the mortality, you don't want that to be 6.5. You want that to be 6.50. So it's the same number of digits. Okay, why do you want it to be the same number of digits?
That way it's, if I visually look it and just want to pick up.
So you want to visually look at it. Would adding that 0 make it easier to visually look at? Or is there another way to sort of show that? What? What? Align the decimals or right justify the columns. Does everybody see that? And that, I claim, would make a difference. Yes, the reason you want to look at this is to compare things. Comparing numbers, you want to right justify it. Does everybody agree with that? That's an important thing, okay? Anything else that you would see that maybe we would simplify here or change? Okay. The one thing that I would notice is that all of these things have zeros as their decimal points, right? I would presumably eliminate the zeros, okay, and make the numbers better. So if we do these kind of things, this was my improved table. Now you may say, well, it's not improved because it's got shading here and the font isn't as good, okay, but that's how I prepared it. But does everybody see, I think that this is an easier table to visualize. First of all, what did we do? We added the commas, okay? We right justified. We eliminated the things that weren't relevant. I bolded highest values. And does that make it more interesting? I think that makes it more interesting, right? Okay? You might even be able to, you could even imagine coloring it in by deciles or something like that. I also did something else that was, I really didn't tell you it. Looking at this kind of plot, does everybody see this big gap of the white space here? Why was that gap of white space here? What? Because the column name was too long, right? How could I fix that? Well, birth rate became 2 words, and suddenly that went away. Does everybody see that? Okay. So the lesson here is to realize that there are ways you can improve tables, even something as dumb as tables, to make them more sensible. Okay? Any questions and more interpretable? And it's important to kind of have this aesthetic, okay? First of all, so you understand them, and second, when you present data like that. Because there are these degrees of freedom that people don't exploit the way that they should. Any questions? Any questions about tables? Okay, good. Another type of data that we see often are line plots, which are, issues where, you have XY plots where the points typically reflect actual data values. And often people connect or interpolate them with lines. Okay? Any questions? So under what conditions is it helpful to take a data plot where you have X values and Y values and connect them with lines? Okay, let's think about it. Does everybody see that sometimes people just plot these things without lines and just plot points, and sometimes they connect them by lines? Why might one be better than the other? Okay?
When we're looking at large number of points, then we might look for the general line thing. But if we have a small range, then we might care about small changes in 2 points. So we might like the first one.
So the first, wait, you mean, okay, so let's think about these things. Under what conditions should you draw points or should you not draw points? Yeah? Well, draw lines or not draw lines, yeah.
Well, I mean, like, if you were sampling shipments, right, and you get a shipment of 100 one month and then a shipment of 200 the next month, drawing a line between them would imply that you're getting less over the, you're getting a value that's descending at other points in that month, right? Whereas,
right.
Like, they're actually just discrete.
So when you connect things with lines, you are in some sense interpolating between them. Does everybody see? That's what the purpose, in some sense, of drawing a line between things are to make it so that you can project points in between them. And there's a question of whether or not that is a good idea or a bad idea, right? In data like this, where there is a lot of variance and where there is, probably little real meaning about this, I would argue the straight line interpolation is probably not the most meaningful thing. Does everybody see that? Sometimes you would want it, like in this case, what is this showing? This is showing points with a regression line between them, right? In this case, it's a regression curve, right? If you have a better fit through the line, through the points, that is probably worth showing, right? Implicitly connecting them by lines is implicitly interpolating, and it may be a dumb interpolation. Does everybody see that? Now here we have a trend where there are lines that are interpolated by lines. Do we like this or not? Let's look at this one up here. Has anyone seen a graph like that? Would we be, yeah? That may be stock prices, and we see that as lines. Would we be better off seeing that as individual points? Would we be better off seeing that as what? Okay? Or not? What are people's aesthetic here? What do people like about this or not? Why does it look different than that? Yeah?
Well, I like that one just because it shows you the high level of variability. Like on the jaggedness of the line sort of implies that it's like something that changes frequently, right?
This sort of shows you variance. What's interesting here is that this one does not highlight points. This one does highlight points, right? Why does this one good even though it's not highlighting the points? What is the thing that makes this thing interesting even though you didn't highlight the points? I'm going to claim it's the fact that you have a lot of points, right? That in this case having a lot of points and a very thin line make this, in my mind, this is a compelling representation. You're right, I am looking here at trends. I am seeing variability. I think this is a good one, right? This one, I don't like as much. I do see the real data. I see that the lines they drew were a lot of ink that didn't really process the data at all. I'm not crazy about this representation, right? This one I like better. Here's one where I just see data and a well-fitted line through it, a well-fitted curve through it, right? The fit, to my mind, adds something to it in ways that the dotted line did not. Any questions? So, again, do not reflexively connect these things, but sometimes think about it. The worst sin that I sometimes see students do is sometimes you have a plot where, you have points, and the x-axis represents categories. Like you could imagine votes for a political candidate, broken down by men and women, and let's say special ethnic groups and things like that. Okay, you could imagine that there's support like this. Would connecting these points by lines mean anything? Absolutely not, right? This is going to be telling you what's the support for that candidate between people who are what, half women and half men? Okay? Does everybody see the interpolation doesn't mean anything? Okay? So you do have to think about what you're showing and why, right? And even something as simple as a line chart. There are things that you're trying to show. And you should have enough fluency in working with these things, okay, to make sure you're showing something you mean to show. Any questions about that? Okay, good. Now, a data representation that I like a lot, often in here we have situations where we have a lot of examples where we have a lot of rows in our data set, where we have a couple of columns that we care about. Scatter plots are good ways to represent each row by a particular point and show what the values of these things are, okay? And, sometimes people can represent these things as point clouds in 3 dimensions or so and fly through it and do all that kind of stuff. Generally speaking, I think scatter plots are a good thing, but I think that 2D scatter plots are about all I'm capable of understanding. Some people, are different, and, maybe there's times when you want to show scatter plots in higher dimensions. One technique which is often very good is if you have data in higher numbers of dimensions, is to project it down to 2 dimensions and plot those rather than try to plot all 100 dimensions. In my lab, we do a lot of experiments with word embeddings that might be 100 dimensions long or 200 dimensions long, and we couldn't possibly understand anything like that. But there are programs that take them and maybe project them onto a random plane. You take a random plane and you project all the points down, you splot them down. And if that plane is not axis oriented, it will kind of capture all of the dimensions in some way. Okay? And then it gives you a 2-dimensional picture that you can often understand better. Any questions about it? So I think scatter plots are good. 2-dimensional scatter plots are good. My students often give me scatter plots that look like this. What is good or bad about a scatter plot that looks like this? Okay, do people like this scatter plot? Can't make out anything. Does that stop the students from giving it to me? No. Okay, in general they say no, because they say scatter plot it, there's a default assumption on the graphic, and they immediately use it. What is wrong with this is that each dot takes up a certain amount of ink, and you have a large number of points here. Does everybody see that? And that if you have a lot of points, what you end up getting is a blotch that doesn't tell you anything. How can we get more information from this plot? What? You're saying a log? Well, this is a scatter plot. In this case, I don't think that there's a log issue. The problem is that there's too many points if you want to take a look at it, right? There are too many points to be viewed with this kind of a dot. Does everybody see that? So how can we do it better? One, some people might say, well, throw out some of your data and don't plot it, and then you got less plots. And that's sometimes the right answer, to subsample your data. But often I find that it's much more compelling to just reduce your dot size. Does everybody see that? This is the same data drawn with a much smaller dot size. And now you see wildly more. You see where the real area of concentration is. You see what the range of outliers are. You get a sense that there are a lot more data points. How many which plot looks like it has more data points? This one or this one? The right one, right? So this gives you a more accurate sense of how much data you actually have, right? So recognizing that often you want to be careful when you see plots that you don't have points obscuring each other. That happens a lot with scatter plots. Any questions about it? Is there any other way we can cure this problem? Okay. Yeah?
Making the dot color transparent.
So one possibility is making the color, the color of the dot transparent. So sometimes what you will do is, instead of having an opaque dot, you will say, give me a dot, but make it very, very pale and make it transparent. So if I have a lot of points overlapping it, it will be, it will show up as being darker, okay? And transparency is one thing you can modulate. I prefer, any other ideas? I personally prefer to modulate color, okay? And let color represent the, the frequency. This is a slightly different data set. This was body mass index, remember, height, weight, and this was a point for every American, okay? This is a plot that did something called a heat map. And in a heat map, what you do is you color points based on frequency. Maybe the color of the point is going to be a reflection of how many points there are in a radius around it. Does everybody see that? And this one is wildly better. I think it's pretty obvious that the heat map is wildly better. If you look at this, you'll say, my God, these Americans, all very heavy, right? And this shows you that that's not where most of the people are living, right? The people are living over here. And it shows you that most of the weights are in a much more narrow range, right? But it still gives you, So I think the point is clear that sometimes you want to use heat maps, okay, especially when your data is so dense that points overlap each other. Does everybody see that if you're weighing somebody's weight in kilograms and you're measuring their height in centimeters, there is going to be a lot of overlap, right? Just because there's only, I mean, how many different ranges of centimeters are there? From 100 centimeters to 200 centimeters is going to be describing just about everyone in the world, right? That's only 100 100 quantiles, right? And if you have them by kilogram, you've only got 80 quantiles here. Does everybody see that? Whenever you have data of finite resolution, you're going to get a lot of duplicates, and they're going to mask each other unless you use a heat map, or maybe if you use transparency of points. Any questions about that? So heat maps are good things, okay, if you can think about that. Any questions? Okay, good. One idea that is a natural generalization of of bubble charts, of scatter plots, is where you would like to represent more than 2 dimensions on a 2-dimensional thing. Does everybody see, if we want to represent 3 dimensions, we could represent a point cloud, and you have X, Y, and Z, and I find that hard to interpret. How can we represent more than 2 dimensions on a scatter plot? What other degrees of freedom do we have to add other dimensions? Yeah? Color the point is 1 degree of freedom. Does everybody see that? And that we could have a color scale, and we'll talk a little bit more later about color scales. But you're right, by letting color mean something, you start to tell about outliers, right? Like if I take a look at this, something funny about Japan, because Japan is, if I look at it, Japan is red when a lot of the other countries here didn't look red, right? What was redness? Redness meant Asia, okay? So that was meaning that it sort of, in this particular plot, the place here, there were relatively few Asian countries. Does everybody see that? Okay. What other things can you do to represent other dimensions? We can have an X, Y points with color in it. Size. Here's a variable for the size of the thing. What did the size represent? Population, right? So India and China are points, but they're big points. Does everybody see that? Okay. And other places are much smaller points. Yeah? You can use shape. Okay, that sometimes you might want to, we might represent, let's say we wanted that we had another dimension of country, okay, we could represent that by the shape of the country. Maybe it could fluctuate, if there were only a couple of classes of country, maybe some countries would be square and some countries would be round and some would be triangular, right? Or maybe there's a warping between the circle and the square, right? And you could imagine different shapes of ovals and oblongs and whatever you would want, right? Anything else we could modulate here to see what freedoms we have? Okay. One freedom might be the question of the shading of the country. Sometimes you have, dot pattern, it's color, but there's also the notion of whether you have like a dot pattern or a mottled pattern or stripes or solid, right? Sometimes you can have a different color going around the outer rim of the circle, like whether it's a solid circle or a dashed circle, right? So bottom line is there's ways you can represent more dimensions that are better than going to 3 dimensions. Representing too many dimensions on that, and you won't see anything, of course, right? But what do people notice when they see this plot? I'm just curious. Does anybody see anything interesting? Just because, again, what is good, what in my mind, what makes a data visualization cool is when there is something you see. What are the interesting things to see here?
There's a linear relation between GDP and health.
Okay, so this tells me that if this is GDP and health, this tells me the richer you are, the healthier you are, right? And is this, what scale is this? Is this a linear scale? That was a logarithmic scale, right? So that kind of shows that you need to, yes, as you get richer, you get healthier, but you need to really double it off, right? And it is probably a bigger, a more profound effect at the beginning parts of the curve than at the end, right? What other things does it show you? What else do people see here that looks interesting? Yeah? The grouping of the continents, that it does seem to be that generally speaking, I mean, this part of the world has historically been North and South America, or in Europe, okay? And this has been Africa, it looks like, right? So the African countries generally are poorer, right? What else do you see? Yeah? Who are the massive? Okay, in terms of size, you appreciate better the outlier size. The fact that China and India each have 1/6 of the world's population in it. The rest of the countries don't matter in a big picture, right? So they matter somewhat, but does everybody see that? What else do you see here when you look at this?
There are more countries on the top right than the bottom.
It looks like there's more countries on the top right than on the bottom left, okay? Maybe that's true. So maybe it is the case that this is that there are, maybe more countries are doing better than they were, okay? Anything else that you see here? What else do you look at? What I look at, I'm always looking at outliers, right? Who are the outliers here? Zimbabwe. Where's Zimbabwe? Zimbabwe, right? So Zimbabwe, my God, are they poor? And the life expectancy shows that, right? South Africa is an outlier. What does that mean? It's a lot richer than any of the than most of the other African, maybe all the other African countries. But their but what this tells me is that their health outcomes are not as good as it should be, right? I think there's a big problem with HIV there, and that's a big problem, right? What other countries are outliers? Do we look at this? Which countries seem to be doing better by its people than they should be? What? Bangladesh. Bangladesh is one that is poor, looks poorer than India, but people are living longer, right? So that's interesting. That tells me something. They must be doing something right, right? Okay. What other things? What other countries do I look as outliers? What? Vietnam looks like an outlier, right? It's poor, but their people are living actually reasonably long lives, right? Okay. What? Russia is an outlier, right? They're relatively wealthy, but they are dying at the same rate as Bangladesh, right? So this is what, in my mind, makes a good visualization, is when there's something there that you want to look at, okay? Any questions about it? So part of this, like I say, we're trying to develop taste for visualizing these things. This, to me, is what makes a good visualization. Any questions? Okay. Let's look at some other, common, let's say, chart types, and go through them. I'm not letting you guys go so fast, so sit. What other, for showing the breakdown of different variables, often people use bar charts or pie charts, right? What are the advantages of pie charts and bar charts? Which is better? This is showing, again, 3 types of things, 3 years. Okay, I think this is showing something about baseball attendance in each of 3 different divisions. Okay, but what is the which do people like better? The bar charts, or the bar charts down here, or the pie charts? Who here likes the bar charts? Okay, so you're telling me that for showing a breakdown of things by, proportionality, 1 year's worth, you're saying that the pie chart does a good job. So the relative sense of which one of these is biggest, you think you capture on a pie chart. Does everybody agree with that? What do we capture better on the bar chart? What? The total amount. This seems like over time the number's getting bigger. you couldn't see that the numbers are getting bigger from the series of pie charts, right? So there are, there's these things people call bar charts. They sometimes call it stacked bar charts because there's multiple pieces here and stuff like that. Some people are fanatics against pie charts. Generally speaking, pie charts, I think, are sometimes misused. I think in a series of pie charts like this, it's hard to make any comparison. One part pie chart probably makes sense. What kind of sins, though, are there for when do pie charts turn out to be bad? Yeah? When you got a lot of different categories and tiny slivers of pie are probably hard to compare, right? So, so you've got to develop your own aesthetic to it. I think that I agree that if you want to show percentages of totality, maybe you're better off with a pie chart. Generally speaking, if you're trying to show trends over time, or if you're trying to show breakdowns over time, okay, I would probably opt for bar charts. Okay? Any questions about that? But these are taste issues. Any questions? Now, which of these pie charts do we like better? Let's take a look at this and make a vote. Okay, these are bar charts of how Republicans did in the primaries. Okay, who likes the left pie chart better? Who likes the right pie chart better? Few people. Why do you like the left pie chart better? What? Ink ratio or Chartjunk. What?
If the colors are similar, like in the first chart, the blue and the navy, they are both similar. So if you just break it apart, they become obviously separate.
You say this color and this color are too close for your taste. So you like the color scale here better. And you're right that there's a difference, and maybe the more muted colors are a little bit better. Okay? But what don't I like about this pie chart? The third dimension. And what else? Is it? Why do you have the white spaces between them? Okay, the answer is obvious, because if you didn't have the white spaces, you couldn't see the third dimension as well, right? Does everybody agree? Okay. So, but if you're going to be trying to use this for comparison, there's no question that the flat, undistorted perspective is better for comparison. Does everybody see that? What else is better about this one than that one?
I think that one is kind of showing the tilted, like it's not flat, so it might be biased towards the other side.
You're saying because this one is not because this one is tilted. Yeah. The tilting perspective is bad. The other good thing, this one actually does show the numbers also, right? So even if you wanted to say for a fairly fine distinction, could you look at this and tell that Kasich is bigger than Rubio? Maybe. Okay, depends upon how sensitive. I can certainly tell when I've got the numbers. I may or may not be able to tell from this pie slice, right? In this particular case, Rubio's pie got smaller as it went away, right? Which happens to be true, but in this particular case. But I think Cruz looks better compared to Trump on this one, right? To my mind, here it looks like Trump kicked Cruz's butt, right? Here, Trump and Cruz look relatively close to each other, right? And that's because of the perspective and the tilt, right? Okay, so when you draw pie charts, it's okay for me if you draw pie charts, but don't give me this three-dimensional nonsense, okay? Any questions about it? Does anybody have any reason why the three-dimensional one's better? Other than looks cool or something like that. It's the default assumption on Excel or something like that. Okay, so that doesn't fit our principles. Any questions? Okay, let me look at one last concept, and then we're going to, I'll let you guys go. And this is that we often want to represent histograms. Okay, often we have a y variable. What does a histogram do? When we have a variable and we have frequency data, a histogram is a way of reporting frequency data. Is that correct? And it basically tells us how many there are at each bin. Okay? Any questions? Histograms are good for showing the equivalent of like probability density functions, right? What about, this is a cumulative density function. What's good or bad about histograms? Let's think about this. Okay, and what degrees of freedom do we have about histograms that can make a difference in how the histogram looks? What? Bin size. How many bins do we have? Okay, here is a plot where I was drawing some points. In this case, this is, it looks like, I think this was 1,000,000 points that I was showing. No, 100,000 points that I was showing from what was drawn